Scatterplots, and equations of lines. So we've worked on this from chapter 1 this year, but we're going to revisit it using different forms of equations of lines. We're going to actually probably use point slope form. So what we're going to do, first of all, you've been given a set of data, and the first step you need to do is to graph that. Usually the top is going to be your x value or your independent variable. The bottom of a table is going to be your dependent variable. It's going to be your y values. In this case, we're just going to talk about fat and calories. The fat, again, goes on the x-axis, so we're going to put fat down here. You want to look to see what is the smallest amount, which happens to be 6, and the largest amount is 36. You want to go up by the same amount. So I need to go somehow from 6 all the way up to 36 on this graph. So I need to probably go up, maybe you can go up by 2s. If I go by 2s, that means I have to have 18 lines. If I go up by 3s, I'd have to have 12 lines. It's up to you how many you want to go up by. Just for, to make it easier, I'm going to actually go up by 2s. But when I write this, I'm not going to actually start. I'm going to start at 0, but I'm not going to put every number down. I'm only going to write down every fifth. So I'm going to go up by 2. So 2, 4, 6, 8, 10. And then it's going to be 20. And each line represents 2. So notice I can get all the way up to 40 for fat, and that's in terms of grams. We want to make sure that we are labeling that. Then on the y-axis, I'm going to notice in that one, we're going to actually use, we're going to label it calories. And I look, the smallest number of calories in this case is going to be 220, and the largest is going to be 633. So I'm going to have to, I got to cover a fairly large section from 200 up to 600, maybe 650. And so what I'm going to do is I'm actually going to cut the graph. I'm going to cut it, and we talked about like that heartbeat on the side. I'm going to cut that graph, and I'm going to actually start at about 200. And each of these are going to go up by 25s. Let's see if that'll work out. So what I mean by that is that every fourth one will be another 100. Okay, and that would get me all the way up to 650. So I started at 200, cut my graph, and now I'm going to graph these points. And that's how you're going to set up your graphs to begin with. You need to make sure that your x and y axis go up by the same amount. Now, your x doesn't have to go up by the same amount that your y is going up by, but they do have to be equal intervals. When I drew the graph for the x-axis, I had a scale of 2. In other words, I went up by 2 numbers every time. When I did the scale for the y-axis, I went up by 25, even though each of the numbers is a difference of 100. So now I'm going to graph these points, 6 and 276. So 6 up 276. It's not going to be exact, but you can get, move that down a little bit. Okay. 7 to 60. 10 to 20. 19, 388. 20, 430. 27, 550. 36, 633. All right, now, as I look at that scatter plot, they do kind of look scattered, but I'm able to see that the graph seems to be, as fat goes up, calories go up. And it seems to be a positive correlation. In other words, it goes up from left to right. So in order to draw a trend line, it's called the best fit line. So what I mean by that is I need to draw a line. I need to go through 2 points so that I can get the slope. And it needs to go in the way that the graph is trending. So I'm going to go through 2 points that is going to go up from left to right. And I got about half of the points on the bottom and half the points on the top of the graph. In this case, I'm going to probably use that was a poor line. Erase that line. Calibration was off a little bit, but I'm going to go through that point and that point. And you do want to use a ruler or a straight edge, okay? And now as I look at this point right here, that point is at 7, 260, and this point was at 36, 633. So we're going to use that point in order to come up with our slope. So we're going to figure our slope. And we're going to find y1 minus y2 all over x1 minus x2. So I'm going to take my first y value, which is 633, subtract my second y value, 260. That's the point that I drew my line through. And then I'm going to take the first x value, which is 36, minus that next x value, which is 7. Then, using our calculators or your brain, you can subtract these, and you're going to find out that it's 373 all over 29. And that's your slope. Now, you can divide that out to get an estimated slope of 12.9. Now, when you write the equation of that line, you're going to start off with slope or point slope form. And point slope form, just remember, y minus, put the slope in, x minus, and put the points in. Use any of the points. You're going to want to use points that are on your line, so you can either one of these points that we chose, either this point or that point or any other point that was on the line that we graphed. Now, everybody's going to probably have a different line graph because usually you're not going to go through the same 2 points as me or as the person next to you. So when you graph this, you are going to choose one of the points that's on your line. I'm going to plug that in. I'm going to use the 36, 633. So in for x, I'm going to put a 36. In for y, I'm going to put 633. And then for the slope, I'm going to actually use that fraction. 373 all over 29. And that is how you get the equation of your trend line. Okay? Now, I'm going to zip through a next example, but I'll give you another example. I'm not going to talk through this. You're going to see. I will tell you, though, when we create this example, we're going to put time. When we're talking about time is usually your independent variable. Time is going to go on the x-axis. Sorry, this is going to be your years. Years are going to be your independent axis. And then the time that they ran their skating times are going to go on the y-axis. Time is going to be based on the year that it is. The problem or the difference with using years, most of the time when we graph these, we're not going to actually graph the year. We're not going to put in 1980. What we're going to do is we're going to actually put 0 in for 1980. And then everything is going to be years since 1980. And so 0 years since 1980 would be 1980. 1984 would be 4 years after 1980. 1988 would be 8 years. 92 would be 12. 94 is 14. 98, 18. And 2002 would be 22. Those are the values you're actually going to graph. And then the time Again, you're going to look at what's the smallest time that you have here. It looks like 382, and the largest time looks to be about 432. So you're going to figure out what that interval is. From 382 to 432 goes up by approximately 50. So I might go up by 5s. So I'm going to, again, cut off my graph a little bit. I'm going to start at 380, and every line. Each of the x-axis is just going up by 2s. The y-axis needs to be extended a little bit, and then I'm plotting my points. Once you've got your line between your 2 points, you want to pick those 2 points, find the slope, and then plug them in. So I'm going to take 422 minus 402. Should have been 0 minus 22. I get 20 all over negative 22, which does reduce. Then I plug it into point slope. Choose any of those points. I'm going to choose 2002. So the y value is 402. The x value is 22.